Hi, everyone, and welcome to the MLOps podcast. I am Dean, your host, and today I have with me Natanel Davidovits. Natanel is an algorithm and AI researcher and manager with over a decade of industry experience. He has mentored early startup teams from initial research to developing innovative enterprise AI solutions, and he's managed data science teams at Nike, Double Verify, and more, with expertise that are spanning classical and deep learning, computer vision, natural language understanding, recommendation systems, multi-physical systems modeling, and optimization. So a bunch of really, really cool things. I hope we get to dive into all of those. Nate, thank you for taking the time.
My pleasure.
So diving right into it, how do you take models and make them really efficient so that they can handle the real world tasks effectively?
Well, first of all, you would want to know where you are running it and what is the price of running it there. So when you are optimizing, you're trying to fit into a box, a certain model with certain parameters that will perform well. And you ideally would want it to be as cheap as possible, but not mitigating the quality. So you would want the model to be as optimized as possible with as little parameters as possible, both because of compute and because of maintenance. Because if you have a lot of parameters, you would need a big data set.
Well, I guess as you're saying this, there's sort of different considerations that might contradict each other. And I'm guessing that the answer to how do you decide is that it depends. But do you have a process from your experience that's sort of would help a team that's thinking about where they should be on this curve between efficiency and performance?
So the approach I prefer is to start small. So the smallest model you can start with just to see you're in square one, just to see what the baseline is and increment from there. Perhaps you don't need more data. Perhaps you need a bigger machine, even with the smallest model you can start with. So you would need to start the thinnest you can and then increase it from there.
Okay, so that makes sense. I sometimes, when I talk to people, especially now with the LLM world, I recommend that people start with having someone else host their model. So use an API like OpenAI or Claude, and only later on graduate to something that they're self-hosting. I know this maybe is more of a new thing because I feel like before LLMs, we didn't really have that many options for something equivalent. But how do you think about like APIs and hosted models versus self-hosting?
Well, for sure, for startups, APIs are better because you can theoretically mitigate the time and just work on the things that differentiates you. And if you are building something that needs to be reserved, like private data, for example, that you cannot send out, so that's an issue. There are some products that you can use and you will pay for them, usually much higher than an open API. But if you need to develop something of your own, try to avoid LLMs for starters.
I think that's a good tip. If you can use hosted models, then start maybe with the strongest model you can to make sure that it works, and then graduate to your own and optimization. If you can't, then start with the smallest thing and simplest thing that you can, see what you get, and then evolve in complexity, which I guess is counterintuitive because it's sort of opposite directions in either case. But I like that. I think that's a good tip, and I would agree with that from my experience. So yeah, go ahead.
It's certainly the opposite from academia. Academia is just, build the biggest, use the most amount of data because the tasks are usually more either general or, it's kind of metric race and they're trying to get higher in the leaderboard. But in the industry, there are more complications.
Yeah. So this actually is a good follow-up question. So in academic research, when you're looking at metrics, it's like accuracy or top five accuracy and things like that. What do you usually define as success metrics in real world context, and how do you get them basically, or how do you decide on what they are?
So if the organization is for profit, and most of them are, basically the metric should be eventually money. You can normalize it all to money. The problem is that usually it's not that direct to cascade that calculation from F1 score, for example, down to dollars.
Mm-hmm.
In between, there are a lot of parameters and variables that you cannot monitor when you're training the data, for example. Sometimes you can, but it adds complexity. and you don't want a lot of complexity, especially when you're starting off. So the best thing is to sit down with product or business development, or if, it depends on who is the customer of that, and understand what is success for them, and then do for them the job to map the whatever score, the default score the model can give you, to the business metric.
Yeah, that makes a lot of sense. I feel like probably you and I have even talked offline in a few events about the miscommunications that might happen between like product and business teams to data science teams. I'm curious if you can give maybe a simple example from your experience on how that looks when it works well. That would probably help a lot of.
Well, when you try and label the data, you would want to emphasize what is good label data and what is bad label data, because it all starts with data. And if it's not a labeled data or not a supervised training type of task, that's different. But the mapping that you want to have is the input to the model diverse enough for whatever it's supposed to solve, and the output is accurate enough, and what does it represent in the real world. And you should let the product people give you even a written or an oral explanation to what does it mean money-wise, or what does it mean in success for the organization. So if you have a different distribution for different classes, they can say, okay, this class we have not too much of, but it's very impactful. And you would know how to parameterize or penalize that metric that is being calculating that class compared to the rest of the class.
I like that. If I'm sort of paraphrasing what you're saying, basically, we as data scientists know a lot of technical terms for high quality performance, but from a product or business perspective, many times is this type of persona or this type of edge case is valuable or very dangerous for us in the business. So we have to emphasize to not having false positives or false negatives. But the business people will not use those terms. So asking them about the value of a certain thing to the business is really, really important. I think you probably agree with me that if data scientists wore the product hat more often than not, then it would improve the communication, because it's probably harder for the product people to wear the data science hat. And I really like that sort of phrasing of the of the. Do you
Maybe
think that? Yeah.
organizations could select data scientists, at least in the past, that have shifted to product. That would be very helpful.
Mm-hmm.
Alongside that, maybe do some training, very rudimentary, but to bring in the product people into what is data science, what is important, what we should pay attention to, not to make them a data scientist, but at least to ease the load in the communication.
I agree with that. I think that makes sense. And so, if we're staying in the realm of real world projects, one of the challenges that we've seen is a lot of times you start a project and you don't have a lot of data, or you have a lot of data, but most of it you don't really understand or know the quality of. How do you approach that challenge?
Well, it depends on the domain in general. Some domains have pre-trained models that you can kind of rely on to do label spreading. Label spreading is a semi-supervised method for thin classification. It's greedy, so you need to be careful. But if you have a lot of data, you can run it through a model, use the embeddings, use the labeled set that you have, and spread them a little bit to increase the data set. If that is not the case and you are starting from scratch, of course, scrape Kaggle and the internet in general manually, of course, to choose data sets that are relevant. If there are no models that can help you to automatically make sense of the data and select automatically, I think the day is not too far that LLMs can help with that. We certainly did some work with that in automatic labeling, and I know that is more and more being the method of choice nowadays, especially for general tasks. In more professional tasks like medical, that's more of an issue. That's because you need expertise to label that. You might have some engineered features, for example, in computer vision in medical, that can help you to filter it out. So you can use algorithms to automatically select data for you to reduce the amount of data to label to add to whatever it is you need to solve.
Yeah, I think that what we've seen, so I think that that's like, these are really good points. And maybe one term that you use that I wasn't familiar with is the label spreading. So just to make sure that I understood what you mean is basically you would have either a few labeled samples, or you would actually manually label a few samples. And then you would use embeddings to find similar samples and sort of cluster them around and say, like, okay, all of the samples that are close enough to the labeled samples, I'm going to give them the same label. Is that correct?
Exactly, exactly,
Okay.
and that is ready out of the box in quite a few packages, and you can build it on your own pretty quickly nowadays.
Yeah, no, I think that that's a great method. I was traveling last month and I gave a talk in ODSC about active learning. So I think active learning, which is basically just using a model to pre-label your data, and then using the metrics that that model provides to decide which data to automatically accept into your data set, which to have a human review, and which to throw out, is something that used to be ridiculous undertaking to build, but now it's becoming something that you can basically use a few tools, string them together, and get a really small cold start, and then everything can like work automatically and accelerate the workflow that you have. I'm curious, like, you're smiling, is that something that you are also seeing in a lot of places, or do you think that's still not fully there technologically?
Yeah, so our expertise in the recent years, very recent, has been drastically commoditized, and the market is changing, and the demand for specific positions of data scientists are changing. And I think we all need to identify the trends and what to emphasize to learn and to be specialized in, to be relevant, to keep being relevant.
Fair enough. So what's your personal take there? Like, what are the things that, if I'm a data scientist listening to this and I already have a bit of experience, but I'm not like super experienced, what should I be focusing on?
I think mapping whatever it is that is covered by LLMs and what startups today are using LLMs to bridge the gap. They are not there yet, but what type of solutions they are trying to create using LLMs. Because a lot of the tasks that LLMs are doing today, and they are getting better at being scaled, are replacing data scientists and data analysts. Just for example, data analysts would need to know SQL queries, and they would need to be very knowledgeable in changing them to get the data that they need to test. Today, there are startups already that are solving this issue. You would have a product person asking the computer, I need to select this type of data set from these dates with these parameters. This would be, of course, linked to the organization database. And at the back, under the hood, and behind the UI, what's going to happen is that an LLM would read his request and turn it into an SQL query and feed the data back to him. Downstream, there might be an automatic visualization and data analysis and maybe even conclusions. So
Mm-hmm.
essentially, you see the data analyst domain being kind of washed. I'm not saying it's that case right now, but it's something to look out for.
I think that sort of on the tech side, I agree with you that there's a very clear trend. The way I think about this is that, and this relates to what we were talking about earlier, is if you start wearing that product hat a bit more and understanding the business a bit more, then maybe you can stay relevant by knowing which questions to ask and spending less time on actually like programming or writing the SQL to ask those questions. And so that's how when I like get asked this question, this is how I tell people I think they should, like, what they should be doing to stay relevant. In a sense, it's sort of graduating everyone to be managers, and you're managing the AI, if you want to use that term, to do the actual work, but someone still needs to direct the systems in a sort of language that makes sense, and also be able to validate the responses. So I've talked a lot about like verification in LLMs. That's still a very big challenge. And I think that being able to verify the results is still very relevant. So that would be like a place you could focus on. Does that map to your intuition as well?
Yeah, Yeah, in fact, quite a few startups have talked to me, especially about this issue. Like we called it in those talks bot delegation. You basically delegate to a bot. The issue then is how do you design the guardrails so you would know at scale that the model is not very much secure of himself and confident of himself and telling you nonsense, basically.
Yeah, the guardrails problem is still unsolved, even though while we're recording this, there's a reInvent, and I saw an announcement that there's now a solution on AWS for hallucinations. I'm going to test that out. It'll be interesting, but I'm still somewhat skeptical that that's going to be solved in the near future, mainly because I think that humans also hallucinate. We just don't call it that. So being able to verify the results is still going to be very valuable, and figuring out a way to do that at scale, that's going to be a very big startup, whoever manages to do that. Now, you were talking about the difference between working with generic data. So at DAGZA, we have customers that work with like security camera videos. Obviously, that's natural domain. There's a lot of example models and things like that. But we have other customers that work with like medical data, as you mentioned, or agricultural data, where the domain is sometimes very different from what most models have been trained on, whether it's embedding models or segmentation, object detection, classification models, etc. How do you deal with specialized domain data when you're getting started? You're trying to build a proof of concept. How would you deal with that?
In any case of startup of any model, I would try, if you have any way to get an embedding encoder, starting off with the linear models for sure, because they have the least amount of bias, and they are, of course, they're scalable. So if you just out of luck just get good scores, you can very easily deploy it. Start small again, but in specific or specialized domain, you really need to be careful not to trust the data that you get. It sounds weird, I guess, but a data scientist should be skeptical of the data, not just the labeling, but even the input. For example, there was a project where there was this X-ray machine that is very prevalent in the hospitals that the solution was deployed, and the model did fairly well on those. But then you deploy the same solution in a different hospital and get horrible results, and you are looking at the data and you don't really see what is the difference. It's not there apparent, but the difference was that the data normalization was not the same because the CT machine was different. It was a different make. So you would have very nuanced changes that the model have learned and done well on. So it's not an overfit, but you would need to do some adaptation or some normalization to take into account any machine. And really, you can do that because the radiologists, the humans that were looking at the data, could have got to the same conclusion from either machine.
Mm-hmm.
So you need to, I guess, normalize the data that you are getting in a way that is not, I would say, fragile or reliable in some way. So it goes into feature engineering and feature normalization or data normalization, but you need to be very mindful of that, because the easiest part here after the EDA, the exploratory data analysis,
Mm-hmm.
the easiest part here is the model, especially today.
I think that the way that I've seen it work is, maybe this is exactly what you're saying with don't trust the data, but like the POC, it's fine if you quote unquote cheat and support only one, CT machine in your example or something like that. But you need to be aware that like every category of your business problem that you're solving, where you're making a decision, that's an assumption you're adding to your system. And so you need to make sure that when you break that assumption, the system continues to function. Probably if you've supported 20 different CT machines and you're adding the first, you're already at the point where you've normalized the data enough to not make that mistake again. But that's a big probably. It's not necessarily true. And things change all the time. Like I think I read a paper somewhere where they were saying something similar, but the difference wasn't the CT, but just the different locations had people with different diseases. So that there were other confounding variables that the model wasn't just familiar with. So it can be other things. And I think that there's this meme running around on Twitter where if you are a data scientist and you look at your data, you're already better than 90% of all data scientists.
That's true.
You should look at your data if you're listening to this. But also, I think that in the domain expert cases, it's much harder to look at your data because you can look at radiology samples, but unless you're a radiologist, they're probably going to mean much less to you, and you won't see the nuances that the model experiences but maybe a radiologist doesn't. And so I think that's a really good point, to not trust your data and sort of build that communication and interface with the experts that can help you build that confidence whenever you change assumptions. Yeah,
There
so
are
I
some
think, yeah, go ahead.
there are some red flags that you can use, and they usually show. They usually pop up, and you should be notable noticing them. So one is, for example, if you have a model that is on the data that you've trained it on, it's very confident, right? And you're getting new data, and it's not that confident on.
Mm-hmm.
So you should understand that something is changed. The data is a bit different. Or another thing you can do is monitor the embedding or the features that you're using. And let's say you have a model that is statistically a representation of the data that you've trained on, for example, a KDE.
Mm-hmm.
And you're getting new data and you're trying to see in that trained KDE, what is the probabilities of the new data? Is it very different from the data that you've trained on? Because the latent space features are as close as possible to a decision. If you see different decisions, you can see some issues.
Fair enough. I think those are great practical tips. If I go back to the conversation we had about LLMs and AI and how they're going to impact the job market, so we spoke about this offline and now a bit online. Obviously, at this point, I think it's clear to everyone that there's something big that's changing. I'm not sure people really understand how that change is going to play out. I know you have a lot of interesting opinions about that. So, aside from what you already mentioned, like where do you think we're going to be at from an NLP expert perspective, or in general a machine learning expert perspective, in the next few years?
I have not so good news and some weird news in what I'm seeing. So what I'm seeing is that, of course, the scale and the cost of LLMs is relatively low compared to a data scientist. And you can see already a shift in the market, especially on NLP. But you would see that as well on computer vision and audio, probably a little later, but audio is also going to be impacted at some point. I think that the general tasks would be impacted the most and the quickest. And usually the big tech companies would hold big LLMs that would probably beat the market, and they would connect them to their APIs and the rest of the automatic machine learning solutions that they have. So it will very quickly be a business person or a very high level tech executive that will be using those solutions, and the teams would be much smaller, if at all. That's good for startups that need that, and it's not their product, but it's a component. So it's a good idea. It's a good idea for them to use it because they would have a leaner organization. For data scientists, that would be, I don't want to be using the word compromise, but they would need to update their expertise. I
Resume.
would, yeah, and not just the resume, but really what they are aspiring to do. They would need to decide whether they want to pursue general tasks and later on a slightly more specialized task, but with a big market. Medical is one of those, and maybe focus on the strength of the rest of the realm of data science. I mean, data science is a rebranding of statistics, basically. Data science is statistics at scale, pretty much. So the next thing beyond that would be automatic data science, which will be data science at scale. So I see it, at least what I can see from right now and what is bubbling up can maybe predict, is that either there will be a shift for some of the people towards product. So you might see data scientists veering towards product. And I would advise those that don't to try and be knowledgeable about domains that are not covered by LLMs in the foreseeable future. For example, sensor fusion. Okay, so sensor fusion would probably not be covered by LLMs anytime soon because it's not general enough. It's very specific, though I must say probably LLMs would get there somewhere because the big organizations are using power factories and they have a lot of sensors, so they might, harvest that and have a sensor fusion LLM eventually.
Yeah.
And general algorithmic solutions are also very important. I think they were left behind. I remember when I was recruiting, many people knew data science, computer vision, and NLP, and very Pythonic knowledge base.
Mm-hmm.
It's something that you can learn from a tutorial, from a course, from project. The basic knowledge is still valuable significantly, especially if you're taking into account the cost of compute and the energy usage. And there are a lot of parallels between cost of compute and edge devices optimization.
Mm-hmm.
And edge devices are very much still a thing. You would still want to. It's not enough to take I don't know, mobile net and quantize it and deploy it. You would want to have something more efficient. It's not that
Mm-hmm.
efficient, and especially with drones nowadays.
Yeah. Yeah. So I think if I sort of add to that, it's pretty clear that the more generic and broad problems are, as you say, going to be solved by big players. And the more specific you are, the more long-term probably value you'll be able to provide because I mean, there's a saying in the startup world that if it's a problem that is really painful and it's painful for a lot of people, then Google is going to solve it or whatever, Microsoft or whoever you want, your favorite giant company. And startups shouldn't look for problems like that. They should look for a problem that's really painful for a small amount of people. And so that's how you should start and then expand the amount of people you solve a problem for, as opposed to choosing a problem that hurts a lot of people a tiny bit, because then they don't care enough to actually do something about that. So, in a sense, I think this translates well to the advice that you're giving. You should be decent at everything, but you should go deep on one thing that ideally is specialized and not like a generic problem. And then maybe expand from that to adjacent areas. But that's probably a better way to guarantee relevancy in the long term market.
Yeah,
Awesome. So now we'll go to high level questions just before we wrap up. So, starting with, what do you think is the hardest unsolved problem in the machine learning and AI space?
definitely robotics.
Hmm.
I think robotics is a big one. There are two aspects of that. So one, obviously, the control and scale of the model that you are needing. Just to remind everyone, autonomous driving cars are not yet a thing. There are very
Waymo might beg to differ, but yeah.
well. I'll believe it when I can buy it.
Fair enough. I rode a Waymo in San Francisco. It was an awesome experience, but there are caveats, right? Like they only do that in cities where they've scanned it, and I don't know if scanning is scalable to the entire world, so it might just be like large cities and everything. And then you have that argument of whether or not that's good enough. But I agree with you that like the vision that I remember from Elon Musk that like everyone will have an autonomous vehicle. You don't need to drive. You don't need like a steering wheel. We're not there yet, but I'm hopeful. So yeah. So sorry, you were saying that's like one problem with.
Yeah. Oh, by the way, for if we are just talking about autonomous cars, in my humble opinion, I think autonomous cars could have worked if we had a critical mass of autonomous cars. It could be relatively predictable. But humans are not. And that has to do a lot with the control of robots, especially in human environment. So you can see in automatic warehouses, good use, very successful use of robots because it's a very distinct environment. It's very hard to generalize on physics, basically.
Mhm.
And so one is robotics that you need to generalize on physics. And another thing is that the mechanics of the current robots are really hard to make intuitive for AI. Because the AI, even if you give it training, initial training, it would need some more to refine its maneuverability. And the mechanics of it is not ideal. I mean, our mechanics is better because it's softer. It takes into account energy usage, energy preservation, and momentum. And if you look at Atlas and other robots, They're very mechanically sharp moving entities.
Yeah, and clumsy. Or I mean, it's not that clumsy, but it looks clumsy. Yeah, I think robotics is actually really interesting. I think in a sense there was a lot of philosophical talk about whether or not you can have AI in the sense of like actual intelligence if it's not an embodied system. Some people would argue that the reason that we are sort of sentient is because we have a body that's ours and everything. I don't subscribe to that philosophy, but I think that there is something about being able to take physical action in the world that relates to how we understand the world. And so it might be related to the process of actually building an AI that can do everything. And I agree with you that there's like engineering challenges in that. And then there's also things where it seems like the way things are working right now is not how you would intuitively expect things to work, but when they succeed eventually. But the counter argument I give to myself on that is that a lot of people didn't think that LLMs are going to scale this well, and they did. So maybe it's good enough, and we just need to wait. And I guess that also relates to my next question. So it's hard to make predictions in this space, but what would you say is going to happen in the next year in machine learning and AI? We're close to the end of this year, so 2025. What are we going to see there?
I can tell you what I wish to see, what I really hope to see. I want to see AI doing, or at least vetting, physics, because we see a lot of, BS in physics, and physics is stagnating horrifically in the last 70 years. For example, string theory is being softly proven. I would like to see some AI that has read all the data, that has also the ability to simulate, to have a thought experiment of its own, and is running multiple thought experiments, and in the end just write down for the string theorist, listen, you should rethink this, guys. So this is my wish, but we'll see.
Fair enough. There was a paper by a research group called Sakana AI. They're based in Japan. And I don't know if you're familiar with this. I forgot the name.
Interesting name.
Yeah. Well, I mean, in Japanese, sakana is fish. But yeah, in Hebrew, sakana is danger. So it's a good choice on their behalf. But they released a paper that was basically like an AI PhD student who's supposed to come up with ideas for papers and then write a paper that sort of is according with the guidelines for submission for real conferences. And it did that. And the cool thing is that it actually conforms to all of the technical rules, but it just invents a lot of code that technically works, but doesn't actually get the results that it claims in the paper. So we're working in that direction. We're not really successful there, but the interesting thing that came out of that is they actually showed that with really sophisticated prompt engineering, you could get not a good PhD student, but a good paper reviewer. So the main output that I got from that talk was that maybe if you're a PhD student now, you should use the prompt that they did to review your work before submitting it so that you sort of improve the quality of your. So we're good enough to review some of these things, but not to create them, which is, I understand, like that's more valuable.
Well, right now, but we'll get there if it really works. I mean, it will also take a bite out of the academics.
Yeah, that's going to be the interesting sort of an interesting inflection point. So let's take some controversial stuff. Tell me something that you think is true about machine learning and AI, but few people would agree with.
Machine learning and AI is something funny because it's saying the same thing twice. What is the difference between AI and machine learning? And I had funny talks with people who are experts, real experts, and they couldn't explain the difference between those two. So my explanation is that AI is Hollywood's way of saying machine learning.
It's written in PowerPoint and not in Python. Yeah, fair enough. And to wrap it up, any recommendations for the audience? It doesn't have to be related to data science.
Ooh, invest in agriculture.
Interesting. Why?
Well, agriculture is very fragile, and we had a very long, peaceful time on planet Earth, but I'm not sure that's going to be the case, not just because of, conflicts and everything, but because we're not paying attention to things that are changing. Aridization, for example, water shortage. The resources are a bit strained, and we need to get a little more local, or at least increase the local production.
Interesting. I like that. It's definitely not a Not a typical recommendation. From my side, I don't know if I have anything new to share. I think that I'm reading some good books, but I want to finish them before I recommend them, just so I know that they're actually worth recommending. So we'll end on that. Invest in agriculture. I think we're living through interesting times. AI or machine learning or data science, however you want to call it, are definitely a part of that, but not the entire picture. And with that, Natanel, thank you so much for taking the time. It was a pleasure.
Thank you.
For the audience, see you next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.